Hi guys, this is Saka, and I promised my regular class that I would do a video for them, so here we go. This is one of the problems from your homework set, and so let's go ahead and read this problem together. So the wavelength of a photon is this many meters. We're solving for the frequency. Okay, so before we start, let's think about what equations we have to begin with. The first one we have is C equals lambda times nu. Okay, and this is our what I call the wave equation. We also have E equals H times nu as well. Now, this one is when we're solving for frequency and wavelength. This one is when we're solving for the energy of the photon. We can see here that they do mention photon, but they're talking about the wavelength of the photon. They're not talking about the energy of the photon. Remember, the energy of the photon is in joules. So I know that we're not going to use this equation for this particular problem. We're going to use this one. Okay? So before we start, let's define our variables. C is always a constant, so that's going to be 3.00 times 10 to the 8th meters per second. And this is wavelength, and I know it's wavelength because of the unit, even if I didn't read the question. So that's 1.43 times 10 to the minus 7th meters. So that means that nu is what we don't know. So I'm going to do some fancy algebra and I'll solve for nu. So we know that C over lambda equals nu. And so what I'm going to do now is just substitute my numbers in. So 3.00 times 10 to the 8th meters per second over 1.43 times 10 to the minus 7th meters. Meters cancels, leaving me with 1 over seconds, which is the unit of frequency. And we can get our answer here. So let me just break out my calculator like you all have to. So 3 times 10 to the 8th divided by 1.43 times 10 to the negative 7th. When we do that, we get 2 point, that rounds to 2.10 times 10 to the 15th 1 over seconds. And here's our answer. Okay, not so bad, right? And if I have time, I'll do another one. Otherwise, I'll definitely do one tomorrow, guys. So enjoy.